ASTM concrete temperature is one of the most important factors, including the quality time of set strength of concrete. Without control of the concrete temperature, predicting the concrete's performance is very difficult, if not impossible. A concrete with a high initial temperature will probably have a higher than normal early strength and lower than normal later strength. The ultimate overall quality of the concrete will also probably be lowered. Conversely, concrete placed and cured at low temperatures will develop strength at a slower rate, but ultimately will have higher strength and be of higher quality. The temperature of concrete is used to indicate the type of curing and protection that will be needed, as well as the length of time curing protection should be maintained. By controlling the concrete temperature within acceptable limits, immediate and future problems may be avoided. When different types of concrete are to be evaluated, the mixing temperature of each concrete should be as identical as possible. Concrete temperature affects the performance of chemical admixtures, air and training admixtures, pozzolanic materials, and other additives and mixtures. Temperature and freshly hydraulic cement concrete. The end of this temperature sensing portion of the temperature measure device is submerged a minimum of 3 to 5 minutes into the freshly concrete, I believe. We'll move on to this because the following is a summary of the key steps involved in measuring the temperature of freshly mixed concrete. The summary is derived from the actual checklist used as ACI performance examination. It can be familiarize yourself with the basic procedures of this method before proceeding with your study as the AST standard itself. However, the summary is not intended to take the place of your complete study of the ASTM standard. Place the temperature of the measuring device, TMD, in the concrete so that sensing proportion submerged a minimum of 3 inches. Gently press around TDM so the ambient outside air temperature does not influence the measured temperature. Leave the TMD temperature measuring device in the concrete for at least 2 minutes, but no more than 5. Read and record fresh concrete temperature to the nearest 0.5 Celsius or 1 degree Fahrenheit. Do not remove the temperature measuring device from the concrete when reading the temperature. Report the measured temperature of the freshly mixed concrete to the nearest 0.5 Celsius or 1 Fahrenheit. Temperature of freshly mixed concrete. The process of testing fresh concrete in the field begins with the procedures from obtaining and preparing the sample of concrete to be tested. ASTM 172-172M gives the standard procedures for obtaining representative samples of batch of concrete for various types of mixing and or agitating equipment. In addition, ASTM 172-172M gives specific time limits regarding when tests for slump and air content must be started, and from the beginning the mold of the test specimens. All too often, it has been the bad habit of technicians to obtain the sample of concrete as quickly as possible. Its arrival at the job site, resulting in sampling the first portion of the batch discharge. This practice is violation of the specifications under which the concrete is being supplied, ASC 301, 318, ASTM C94, 94M, and may result in a non-representative sample of concrete. When you consider the specifications may only require strength tests to be made once every 100 cubic yards or every 150 cubic yards, then a need for a truly representative sample becomes readily apparent. The minimum 1 cubic foot to 28 liter sample of concrete from which the compressive strength test specimen will be made represents only 0.025 to 0.037% of total amount of concrete placed. To assure accuracy in testing of fresh concrete, every precaution should be taken to obtain a sample of concrete which is truly representative of the entire batch, and then to protect the sample from damaging effects of evaporation and contamination. The following is a summary of the key steps involved in sampling freshly mixed concrete. The summary is designed from the actual checklist used in the ACI performance examination. It can be used to familiar yourself with the basic procedures of this method before proceeding with your study of the ASTM standards itself. However, the summary is not intended to take the place of your complete study of the ASTM standards. One or more procedures sampling freshly mixed concrete. One or more procedures on the checklist are in the form of verbal questions. You will be expected to verbally provide all information in the response indicated in boldface. What must occur before a sample of concrete can be taken from a revolving drum mixer? All water and admixtures must be added to the mixture. 2. The sampling from a revolving drum mixer. What is collected and when is it taken during discharge? In 2 or more portions of concrete at regular spaced intervals from the middle of the batch. How are the sample portions obtained from the discharge stream of a stationary or revolving drum mixer? Repeatedly pass the receptacle through the entire discharge stream. Completely divert this discharge stream into a sample container. Describe the procedure for collecting a sample for a paving mixer. Discharge the content of a paving mixer. Obtain samples from at least 5 different portions of the pile. What is the maximum size of sample when strength test specimens are to be molded? 28 liters. What is the maximum allowable time between obtaining the first and final portions of the composite sample? What is the maximum allowable time? The minimum size for a sample when strength test specimens are to be molded is 1 feet cubed, or 28 liters. What action is to require after the individual concrete samples have been transported to the place where tests are to be performed? Combine and remix the samples with a shovel. What should be done if concrete contains aggregate larger than it is appropriate for the size of the molds of the equipment being used? Wet sieving. Start the test slump temperature and air content within how many minutes after obtaining final portions of the composite sample? 5 minutes. Start molding specimens for strength tests within how many minutes after fabricating the composite sample? 15 minutes. From what must the concrete sample be protected? Sun, wind, and rapid evaporation or contamination. The following is a summary of sampling fresh concrete alternative performance only. The following is a summary of the key steps involved in sampling freshly concrete. The summary is derived from the actual checklist used in the ACI performance examination. It can be used to familiar yourself with the basic procedures of this method before proceeding with your study of ASTM standards itself. However, this summary is not intended to take the place of your complete study of the ASTM standards. Obtain a representative sample. Example, revolving drum mixer. Ensure that all water has been added. Sample the concrete at 2 or more regular spaced intervals during discharge of the middle portion of the batch. Repeat, pass receptacle through entire discharge stream and completely divert discharge stream into sampling containers. Transport samples to the testing center. Combine and mix to form composite samples. Obtain composite sample within 15 minutes from the start of the sampling. Minimum size of sample used for the strength test shall be 28 liters, 1 feet, or 1 cubed feet. Start some test for slump and air content within 5 minutes after obtaining final portions of the composite sample. Start mold specimens within 15 minutes after fabricating the composite sample. Protect sample against rapid evaporation and contamination. Standard test method for slump of hydraulic concrete, cement concrete. The purpose of the slump test is to determine the consistency of the concrete. This is to measure the relative fluidity and mobility of the concrete mixture. Slump does not measure the water content or workability of the concrete. It is true that an increase or decrease in the water content will cause a corresponding increase or decrease in the slump of the concrete, provided that all of the other materials and conditions are consistent. However, many factors can cause the slump of the concrete to change without any change in the water content. Also, the water content may increase or decrease without any apparent change in the slump of the concrete. Factors such as changing aggregate properties or grading, mixed proportions, air content, concrete temperature, or the use of special admixtures can influence the slump of the concrete, or conversely can result in change in the water content requirements for maintaining a given slump. For example, an over-sanded mix may require more mixing water than the original design mix proportions call for, but the slump may remain the same. Therefore, you cannot assume that the water-cement ratio is being maintained simply because the slump is within the specific limitations. The following summary: slump of hydraulic cement concrete. Following is a summary of the key steps involved in determining the slump of the hydraulic cement concrete. The summary is derived from the actual checklist used in the ABC1 performance examination. It can be used to familiarize yourself with basic procedures of this method before proceeding with your study of ASTM standards itself. However, this summary is not intended to take the place of your complete study of the ASTM standards. Dampen the mold. Slump test. Dampen the mold. Place the mold on a rigid, flat, level, moist, and non-absorbent surface free of vibration that is large enough to contain all of the slump concrete. Hold the mold firmly in place during and filling the cleaning by standing on 2 foot pieces on either side of the mold. A base plate with clamps is also acceptable. Using a scoop, fill the mold in 3 layers, moving the scoop around the perimeter of the mold opening to ensure an even distribution of concrete for the first layer. Fill the mold to approximately a third of its volume, 2 5/8 inches, 70 millimeters. Raw the layer 25 times throughout its depth within the rounded end of the tamping rod. Uniformly distribute the strokes over the cross-section of the layer. Incline the rod slightly, starting near the perimeter, and progress with vertical strokes spirally toward the center. For the second layer, fill the mold to approximately 2/3 of the volume, 6 1/8 inch, 160 millimeters. Raw the layer 25 times uniformly over the cross-section with the rounded end of the rod. Raw the layer and into the layer below approximately 1 inch, 25 millimeters. Uniformly distribute the strokes over the cross-section of the layer. For the third layer, heap concrete above the top of the mold. Heap concrete above the top of the mold. Raw the layer 25 times